Hi everyone, and welcome to this cloud generation tutorial. My name is Mats and I'm a senior technical director with focus on look development and effects. In this tutorial we're going to create a tool that will generate different shapes of clouds for each frame in our scene. This will be a point-based cloud generator, which means it's very efficient and very responsive in the viewport. As a final step, we're going to stamp these cloud variations onto a grid. So let me break this down for you. We start by creating a single point in space. We then replicate that point into more points in a spherical shape. We then assign a random scale value to all these points using the p-scale attribute in Houdini. We convert these points to a volume, we flatten the bottom of it, and as a final step we add some fine noise to break up the shapes of these clouds. Okay guys, so we are in Houdini. The first thing I'm going to do is create a geometry SOP. I'm going to name this just Cloud Maker, for instance. Hit I to jump in, and from here I am going to start by adding the add SOP and check this checkbox. That will give me one single point in space. From here I'm going to use the point replicate, that is. We plug that in, and what happens now is it'll replicate that point into a cube shape. We don't want that cube shape, so I'm going to change it to sphere. I'm also going to temporarily just increase the x-axis of the point scatter. So now we have sort of a lumpy representation of what the cloud would look like. Also we're going to add a noise, and I like to use the sparse convolution noise. That gives me a bit more contrast in the variety of shapes. If I run through this offset here, you can see that we get a fairly large contrast in the shapes. It's a bit too crazy maybe, so if you don't like that, just add a bit of frequency to it and it shouldn't be that crazy. So I'm going to leave it like this for now. Now a really fast way of visualizing this cloud setup before you do a volume is to hit the D in the viewport here and use disks for the particle display. That will show you the p-scale value for the points. So currently we don't have a p-scale attribute and it's defaulting to 0.1, but we are going to add that by using an attribute randomize SOP. We plug that in, and by default it's using color, which we don't want, so I'm just going to type in p-scale here, and currently not doing anything either. That's because it's currently set to a three-dimensional, a vector, but the p-scale is actually a single float value. So when I hit that, now we're getting 0 to 1 in p-scale sizes. We can't see because they're really large, but if I pull this back, you can see that we are getting randomized values between 0 and 1. So for now, I'm just going to leave this value at 0.25. So you can see we kind of need to fill in that shape a bit. There's a bunch of holes there. So I'm going to start off by just increasing the quantity of points for my point replicate. So 250 for now should be a good value. Now if I run through the offset now on the noise, you see that we can get a nice variety of shapes for our clouds just by running through this offset. So the first thing I'm going to do is connect this offset to the frame number. To do that, you just say $F, and I'm going to multiply it with, let's say, 100, just to make sure I'm moving far enough in the offset for the noise to get different shapes. So now if I scrub the timeline, so you can see now we have randomized shapes for each frame, and from here we can now stamp these frame numbers onto a grid and get an infinite amount of different shapes. So let's do that. We're going to do a copy stamp because we want to copy the clouds, but we also want to stamp values for the frame number. I'm going to create the grid up here and just visualize that for a second. So here's the grid. I want it to face the camera, and I don't need polygons. I'm going to use points. I'm going to pull out a bit, and I'm going to make this fairly large in preparation for our clouds, and I definitely don't want that many clouds right now. I'm just going to do 9 for now, 3 by 3. And if we just plug this in now, you'll see that it will copy the current cloud that we have, and it's the exact same cloud. So what we need to do now is stamp the frame number and say that each point of this grid should equal the frame number. So we're essentially just utilizing the point numbers from the grid to plug those into a time shift node that we're going to create. So first thing we're going to do is say stamp inputs. We're going to type in a variable name that could be anything. I'm just going to call it frame NR for frame number. And the value that we're looking for is the point numbers from the grid, and those we can fetch by typing at ptnum for point number. So now we're saying frame number equals the point numbers from the grid. So that's 0 to 8 in Houdini. And the final thing that we do then is just to shift the time like this on the left side of our setup. By default, this is set to frame. So we need to break this connection by just deleting the channel and type in our own expression. And we're going to use the stamp expression to do that. So stamp and then parentheses, and now you get all this information here. And essentially what we need is we need the path to the copy node. So we're going to hop out one step and type copy 1. So that's the path, and then we put a comma. Now we need the variable name, which in my case is frame NR, and we need a default value in case this doesn't work. So I'm going to put 0 because that is the first point number that we are using. So now when I hit enter, you can see we have a variety of shapes, a different shape for each point, and they represent the frame numbers. So this is a pretty fast way of stamping up these shapes without having to use multiple variables here. Your other option would be to, for instance, take this offset and actually stamp it in here instead, but I believe it's a bit faster to just shift the time and only have one value to worry about as far as the stamping goes. Now from here we can very easily just add more clouds and get more shapes, which this is a great way to show your supervisor or your client what kind of shapes that you're getting, and they can sort of pick and choose, and you can adjust things together. It's very fast because we're still only looking at points. We're not looking at a volume right now. So what do we want to do here to vary it a bit more? Maybe we want to randomize a lot of these values. So let's say, for instance, the scale of each point, we can randomize that as well, and that's fairly easy to do. You have a global seed here, so we can take this value and just multiply that with frame, again, $F. So now the p-scale values will vary for each cloud as well. We can also go to the point replicate node here and type in some better expressions here for the shape. So right now every cloud is a size of 3 meters in width. So let's say we want to stamp that as well. So to do that, because we just want it to shift per frame, we don't really want to stamp this value. To do that, you type in a fit 01, and we need a random function based on $frame multiplied by 0 point some arbitrary value, and we want to fit that between 1 and 3, and finally we end up with a parenthesis. And now you can see some are 3 and some are 1. We can also do the same thing for the height and for the depth of the cloud. But right now let's kind of leave it where it is, and let's start to sort of adjust some things here. We can, for instance, start pulling this a bit and see what happens. Now if I crank this up, you see that some of these clouds, before I do that actually, let me just try to maybe lower the p-scale a bit again just to see. Yeah, let's stay here. Now you can see some of these are really large, and we're getting some holes in here. We actually need more points in the shapes that are larger. So to do that, we can go into the quantity here and multiply these points with the uniform scale, and also with the x scale. So let's first off put the same expression into the scale. So generally we want to uniformly scale. I'm just going to change this number to something else and leave that the way it is. If I hit enter now, you'll see now we're getting quite large variety in shapes, and that's not a bad thing. So let's go back here and just go back to 9 clouds for now, I am going to just increase the size of my grid a bit, like this, like so. And now I'm going to go back and actually adjust the p-scale again and try to get to a point where I'm filling in those shapes. So let's say we do something like this, and like I said before, we want to have more points in here, so in the large shape. So let's go back to the point replicate and look at this here. So we want to take this, I'm going to do a copy parameter, just copy this value and multiply the points with that. So I'm going to hit multiply, right click and say paste relative reference. So now you can see we're getting more points in the larger shapes. So maybe that's not enough. It still looks like it's kind of got some holes and stuff. So what we can do is we can double that scale value in here in the expression. So we isolate this channel value here by adding a parenthesis and thus multiplying it with 2 and ending it with a parenthesis. So now we're getting even more points in the large shapes. Now I can also see that some of the points are really small, so one way that you can adjust this 0 to 1 bias here is by not using a uniform value here but choosing the custom ramp. This will let you change the bias of 0 to 1. It also lets you fit these values, so this is really nice. I can say my smallest point should not be 0, it should be a little bit larger, and maybe my largest point should be twice as large. But I don't want it to be a 50-50 thing. I want only a few of my points to be that large, so I'm going to pull this up a bit. Alright, that's that. Now maybe I will go back again and generally lower the scale a bit, like that. And this is not so bad. This is a great start. Let's pull some more rows and see what happens, see what we get. Yeah, that's very interesting. So we have a good variety of shapes here. You can doodle and change these values all you want all day long until you get something that you like. But this is essentially the basic setup. It's very fast, and all we are doing is stamping one single value and using our frame numbers to randomize everything. So this is quite efficient. Now from here, let's go back and not have that many clouds. So let's go back to those 9 again. Now, and I'm sorry, that's my dog. He snores a lot. If you hear him, please excuse him. He is in the background, and unfortunately he snores. That's just the way it is. Now from here, we want to convert everything to a cloud. So Houdini has this cloud sop that works fine for this. I'm going to plug that in here, and as you can see, nothing is happening now. Let's go back to the single point here. Nothing is happening because the source is set to polygonal model. Now we're not going to use that because it's kind of slow. I want to use my point cloud instead. So we switch that, and now we do have a volume here. So let's zoom in. I'm going to create a new camera so that I have something to visualize close up with. And I'm not a big fan of using a 50mm lens because it gives a lot of distortion. If I'm looking at something for the shape, I want to use a long lens. So I'm going to use a 200mm lens to move in and then pull out a bit. Oh, I'm sorry. Don't forget to lock the camera if you're moving it, like this. Now, a couple things. It's fairly low res, so we want to up the resolution, but first we need lights. You really need to put lights in the viewport when you're handling volumes, because how else are you going to see what this is going to look like? You can see it's got a bunch of singular points just kind of hanging out there, and that's fine. Let's leave this for now, and let's just add some lights. So I'm going to add a distant light over here. I'm going to rotate this down and have it sort of represent the sunlight from the back, kind of like this. I'm going to do a copy and paste, hit T, and just transform that over here. Hit R again and rotate this up a bit, so that will be this will be my sort of atmospheric light. I'm going to lower this a bit so it's not so prominent, and for this light I like to use a cool color like bluish, like so. And for the other light, the sunlight, I will use a warm color, meaning a lower temperature, like that. Alright, so now we're getting somewhere. I'm just going to hide these lights for now by doing that, and just to make sure I don't ever see them, I will hide them there as well. And I like to use a background now that's light when I have this cloud, because the sky is never completely black, right? So if we hit D here in the viewport, you can go to background and hit light, and then hit D again to remove that display. So now we're here. I feel like it fits a bit better in the viewport now. I can also see that it's, like I said before, it's very low res. The shadows are harsh, so let's adjust that right now. You will click on the cloud, and I'm going to lower the density to 1. But when I up the quality, you'll see that we'll get a much better representation. So there we go. Now we have a bunch of scattered points here. We have all these single points hanging out. That's fine. We're gonna adjust all that. The key thing is to add a noise after this, and then it's really all about what you prefer as far as an artist. What kind of look are you going for? Now, what I like to do first, if you were going for a hero cloud type look, then I like to flatten the cloud in the bottom, which you can do here in the cloud swap by clicking this flatten thing, and then you just push up this bottom scale. As you can see, it starts to cut the bottom of the cloud. So I'm going to keep it here. I'm going to change my camera a little bit so that I'm looking at more of a front angle like this. Now, we want to add a noise to this, right? So Houdini has a built-in cloud noise like this. You crank that in there and activate it, and then we start pushing that noise. Now, as you can see, it's giving us a pretty nice look already. If this is what you're going for and you like these points that are kind of sticking out. Now we can hop frame numbers here and see what did the other clouds look like. So this is really not a bad start. Each cloud looks puffy and fluffy and nice. Yeah, that's not bad. So let's go back to 1. Now what we can do is from here you can do a couple of tweaks in this noise. You can, for instance, do a fall off of the noise. If I turn that on, you will get no noise in the bottom, but I can bring some back by just lowering this. You can see it's giving me some of that noise back in the bottom now. And then we can crank it a bit more, and you can see that we're getting much more noise here up top. So it's not a bad look if you want to see what this looks like in really high resolution, because some of the small detail you're not going to see unless you push up your resolution. So let's do that by going to 500 here in the sampling divisions. We're going to wait a couple seconds. Now, as you can see, the cloud noise is what's cooking right now, and it's not very fast. Let's go back to 200 here. I think it's maybe not so happy that I'm recording 4K at the same time as I'm doing this. So let's stay here around 200. Now from here, I can go back to the stamp. Just keep in mind, this is going to take a while if you have a lot of clouds. We have 9, so let's try it. Let's see what happens. We should be okay. I'm going to pull back out now and just take a look at what we have as far as clouds. So here we go. We have a fairly nice set of clouds. I'm going to create a new camera here in case I want to render. And the first camera I'm going to call cam close-up. And the other one I'm going to leave as is. So my cameras, I'm going to put them over here. Now, like I said, that's one way of doing the noise. There is, however, a much faster way of doing it. As far as calculation time, the cloud noise is a bit slow. So let's go back to our single cloud that we had here. And I'm going to go to my close-up camera. So now we're in here and we are looking at our original points that we had before we're adding noise. So what we can do is we can use a custom volume VOP instead to add our own noise to this thing. And what we want to do is we want to first convert this, because right now it's a VDB, so we want to do a convert VDB to a volume, so that's already set there for us. Now I'm going to connect this to my volume VOP and activate that. Now we're going to jump in here, and what we want to do is we want to displace the position of the voxels and push that back into the density. That's fairly easy to do. You use a volume sample like so. We plug the operator input 1 into the file name here, and then we want to use a, let's say, a turbulent noise like this. We need a position data to plug in there. We also want this to be a three-dimensional noise, and let's use original Perlin for instance. And then I'm going to do an add here and add that noise position to the original position, and then plug that sum into the sample position of this volume sample. And then that goes back into the density. Now if you look at it, we are displacing fairly heavily in this thing, and you can see that it's actually cutting off our volume here. Now to avoid that problem, we need to resize our volume. You can do that by typing volume resize, like this. And you have to excuse my dog, he's snoring a little bit now. Now what we're going to do is we're going to do a union here and plug in this into our second input, and that these then get grayed out, so that means it's reading our original bounce. And we're going to turn this off. We don't want to use point bounce, we want to use voxel bounce. And now I can actually add a value to increase the size of that voxel there. So if I hit 40, something is happening. I'm going to keep going and see, maybe that is my noise that's actually just doing that. So let's hop back in here and right click the turbulent noise and do a input parameter creation and hop out. So now we have the noise values here. Let's see if I just start to tweak this a bit. Maybe that is actually not being cut off, it's just the noise being funny. So let's hop a bit over. Okay, so here we go. So as you can see now, we've added our own noise. It's looking pretty cool, and it's actually much faster than the built-in noise in Houdini. So if this is more of the look you're going for, then by all means use this setup instead. So all you have to do now, of course, to hop over and use that instead, is to just plug this into the time shift node instead, and then do the copy stamping again. So I'm gonna zoom out. Actually, I'm just gonna hop into camera 2, and that should give us all the stamped clouds. Now as you can see, we're getting some pretty nice shapes here. We're still cutting the bottom of this these clouds, so if you don't want to do that, then of course you can just turn that off if you're looking for a more of a sort of realistic circular cloud type thing. So I turn that off, and we're just going to let it think for a second, and you'll see now that we're getting no cutoff in the bottom. So this is a great way of creating your clouds, and if you want to from here save these out and actually run the time shift on a file sequence instead, I would highly recommend that if you're creating, let's say, a cloudscape. So let's try to do that. First, we want to save these clouds out. So let's say we save out 9 clouds essentially. So we'll do file cache. First, we want to convert these back to VDB if you want to use it in other renderers, like and in other softwares, of course. It's always good to use VDBs instead. So let's convert it back to a VDB by doing this, convert to VDB. Now I'm going to use the name of this SOP as the file name. So I'm just going to say cloud toot for tutorial. And I'm going to revert this to the defaults, and I don't want to use the file name because that is never a good idea. I'm going to do this. I want a folder with the SOP name and then the actual name of the cloud, and I want to use a VDB and not a Houdini geometry. I'm going to do 9 frames, so I'm going to do frame 0 to 8, like this, and I'm going to hit render and speed this up, and I'll be back in a sec. Now I'm going to say load from disk, and if we go through here, we now have 9 different clouds that we can use. Now I'm just going to hide the camera because I can see that inside the cloud there. Now to stamp these clouds out, we can just connect this time shift node to that cloud, and that should work automatically. The one thing I highly recommend doing if you're in Houdini is to go to the load from file tab and tell this to load as a packed disk primitive. If you do that, you get a bounding box. You can display it full geometry if you want as well, but it's really nice to have a bounding box when you start to stamp things out. So now I've turned that on, and you can see, we can see by the bounding box that we do have our different shapes here, just the way we had before. I'm going to hit save, and now I'm going to say display as full geometry. Hopefully it will not crash. Cool, so that works. So now you have 9 clouds. You can load them up in whatever software you want, export them to 3D Max, or you know, use Octane and Redshift and whichever renderer you prefer, and sort of create your own cloudscape. Okay guys, so that's it. Thank you so much for watching. I hope you get to do some cool cloudscapes from this. It's fairly simple, but it's a very efficient way of creating some fairly good looking clouds that you can stamp out and do some cool stuff with. Now if you're interested in seeing some of my work, I have a Vimeo page. I also have a website at www.vfxsouth.se, and there you can actually sign up if you want to be notified whenever I release any more tutorials. And please also give me feedback if you want. I would love to hear what you guys think. Thank you, and take care of yourselves.